Hi, the saga with this power supply continues. Coming up next. Greetings, the Astro 30 here yet again, working on this power supply project. Now you may remember from the last video I blew up some components. I blew up the NE5534 and somehow I managed to blow the LED because that's now open. I've replaced it, so that's another reason why the constant current circuit isn't going to work. And I had to use a bipolar supply in the end to get this circuit to behave, because having the charge pump in the circuit there was adding voltage to the positive rail, and we don't want to do that. I may have inadvertently, from the schematic I got it from, was that Chinese 0 to 30 volt 3 amp power supply built many years ago. I may have inadvertently forgot to put a component on that was necessary to stop that from happening. I don't know, I can't see anything on the schematic which would do that, so I'm at a loss. Now you may notice there is a change over here in the circuit. Well, I'm still using a split supply, but now instead of going from 0, 15 to 0 to 12 as I had it before, or 15, whatever I had it set at, to give me a 0 volt rail on the power supply, and then use from the 0 volt rail and the positive for the circuit, and from the 0 volt rail and the negative to give me my negative supply. I'm now running off of two separate transformer windings. I've got a 12 volt winding going into this little circuit here, which is a half wave rectifier, rectifying the negative half going cycle, into a little smoothing capacitor here, into a 7905 regulator. Now, Jaycar don't sell 79L05 regulators. I don't even know if they make them. Someone in the comments, please let me know. So anyway, I'm using a 1 amp regulator which only needs to deliver 60 mA to the circuit. Now I've got the LM317T out of circuit, I've got the positive rail disconnected. The only thing left in the circuit is that op amp, but it's dead anyway, so it makes no difference. So now I'm ready to test this little regulator circuit down here to see if I do indeed get negative 5 volts. But let me first show you a circuit diagram. Right, please excuse the crudity of this diagram. I didn't have time to draw it to scale or to paint it. Please comment below if you want me to stop saying that. Anyhow, here's our transformer. We've got the 15 volt winding, 0 going into the diode bridge rectifier and the 15 volt respectively. And that forms our positive and negative rails, which goes through our main filter cap out to power our adjustable regulator circuit. Common there. We've got the 12 volt winding with the 12 volt winding connected directly to the negative rail, and then the 0 of that, so these are in phase with each other. We could use two separate transformers, and I don't think phase would be an issue then. And then we're going through this half wave rectifier, rectifying only the negative going cycle through this small 47 microfarad 50 volt smoothing capacitor, which is positive is connected to the common rail. Then it goes into the 7905. This can take up to minus 25 volt, but I've kept it at 12 volt, which after rectification or rectification, whichever you want to call it, and smoothing, we get roughly about, I think it's 15-16 volts. I haven't actually measured it to verify. I did calculate it, I think it was 16.8. But this can handle minus 25 volt going into it just fine, so we don't need to put any form of Zener dropping there or anything. And then we get our negative 5 volt reference out here, by smoothed with this 1000 microfarad capacitor, positive also going to common. Now will this inject hum into this section? Well, in theory it shouldn't, but I'd actually have to test it by hooking it up to an audio amplifier circuit once I've tested it fully, and just make sure there's no noise coming out the speaker that shouldn't be there. If there's no hum or noise, then no, it shouldn't. So anyway, let's test this little concoction and see what happens. Right, so my meter is measuring the output of the regulator. Now every time I build something, I expect the fucker to go off with a bang when I first plug it in. So, plug it in, excuse my hands. And we got minus 4.93 there on the output, which is not bad. I believe you can see that. So yeah, it's giving me a 5 volt negative rail. Just out of interest, and that's with respect to the common line by the way, just out of interest, what's my input voltage? 16.64, so yeah, I was roughly right about 16.6, I said 16.8. So now I'll measure between the positive rail and the negative rail here. We should only have whatever the transformer puts out, which is 20 volt. 20 volts, so we're not feeding any extra voltage back into the positive section of the main supply as the other circuit was doing, the charge pump, which is nasty. So now across the negative output from the 5 volt regulator we should have close to 25 volts, and yes we do. So I now know that this circuit is working absolutely fine. Alright, so all the circuitry is back together again. I'll just plug the positive wire back into the circuit because it can go there now. I've got the new LED installed, got the new NE5534 installed, the LM317T is reinstalled, and everything is now connected together with each other. So now we plug it in and see what happens. Always a bit dubious after making a change. We have absolutely diddly squat. Okay, well that's because I haven't got the meter plugged onto the output. I've just got a lead plugged onto it, a random lead. Where's my positive lead gone? There it is. No, that's better. Now we've got 14.8 volts out. You can watch the meter whilst I play with my pot. Yes, the voltage increases. I don't know how we're getting 23 volt out. Oh yeah, because we've got a floating negative, that's why. So we're getting a little bit more out of it than we expect. And well, it's not gone back down to 0. Oh, I see why, because I'm measuring from off of the negative 5 volt regulator. That would be stupid. So now I'll re-zero it out whilst I'm measuring from the correct point. And actually put it to 0 might help too. As I said in the last video, I'm a dumbass. Okay, here we go. Right. Okay. Now with the regulator in there, the 5 volt one, it should actually keep this output more stable at 0. That's what I mean. If I can get it to go to 0, it would be nice. Might need a slightly higher value pot like 2K instead of 1K because this is very, very, very touchy. There we go, got 0. Yay. And our maximum output should now be, yeah, 18. That sounds a bit more realistic. Okay, now I'll connect the load. And I don't know if you can see it, it might be out of shot. The test light is glowing dimly. Now I'll test my current limiting. Still doesn't work. Okay, well that's interesting. Right, now it's working. I found the problem. It doesn't like this 100 nanofarad capacitor across the output. Kind of not makes the current limiting work correctly. So I want to know, so currently with the test light on there, I've got the current limited down to 0.355 volt. So that means we should have a current going into a load of 4 ohms. It's roughly limited down to 87 milliamps. There you go, that's what's flowing in the test light at the moment. So now what I want to know is, have I actually destroyed the original NE5532? I know I destroyed the LED, but that could have happened when I plugged the other NE534 in to confirm whether or not the other one was stuffed, and put it in one pin out and blew the shit out of it. So I'll just find what I did with that one, and I'll pop it back in and see what happens. No, it's not. It's not stuffed. It's working perfectly fine. So all that issue with the current limiting not working of that frigging output capacitor. Out of current limiting, in current limiting, out of current limiting, in current limiting. And what did I do with that capacitor? Just to prove that I'm not going completely insane, I'll plug the capacitor back in to the output. If I so can, I'll just hold it there. Take it out of current limiting. Now it won't go back into current limiting. Remove the capacitor, goes back into current limiting. So you have to be careful of what capacitance you put on the output, or current limiting will not work. Yippee-ki-yay, mother... Alright, back to my original testing I was going to do in the last video. I want to know what our voltage drop is going to be across these two 5-watt resistors here when we have this 1 ohm 10 watt resistor across the output, and we're roughly at 1 volt, so we're drawing 1 amp. So we can figure out how this comparator circuit is actually working. So I'll just plug it in now. Got it currently set to 0 volts. So I'll wind it up until it gets to 1. Whoa, too far. Yeah, close. Really need a 10 turn pot here to get it really precise. That's close enough. Right, so we should be dissipating 1 watt, 1 amp in that resistor. And boom, current limiting works, great, okay. Just till it goes off current limiting. Now, I need to move the negative of my meter to this side of the resistor network. We've got about 150 millivolts there. Okay, so from this side of the resistor to the output here, we've got 150 millivolts drop, roughly, across those two resistors, which is being fed into pin 3 of the IC. And using Ohm's law, of course, if we do that calculation, we plug in 150 millivolts divided by the resistance, which is 0.2, it's more closer to 750 milliamps, thereabouts. It's not 100% accurate, but it gives us an idea. So what I want to know now is what's going into pin 2. So we've actually got the output voltage across here, so it's harder to measure what the voltage going into pin 2 is relative to what's coming in to there. If I adjust the pot, we're in current limiting, but it's saying on pin 2 there's 250 millivolts, so that's only just giving us what the output voltage is really. So what does this mean? Well, it means that the circuit is actually functioning. Current limiting is working, but I don't know how precise it is because of the pot. Probably a lower value pot would have been better. I don't know. But for what it is working. I'm dumping an amp into this 10 watt resistor, and well, it seems to be holding up okay. The 317T is getting slightly warm, so it really should be on its own heatsink. And that is absolutely getting hot. My output heatsink is hot. So I know that transistor is passing the current. So I might lower the voltage right off so it's not dumping so much current. Next would be to see what sort of capacitance on the output here actually affects the current limiting, if at all. Okay, got a 2.2 microfarad capacitor here, 63 volt. Make sure I get it the correct polarity or I'll blow the shit out of it. Although that would make for some great video, but I don't really want to have shrapnel going everywhere, and I also value my hearing at the moment. Okay, let's connect it in and plug it in. Okay. Current limiting still works, so fine. It just didn't like the 100 nanofarad ceramic capacitor on the output. So you can have a small capacitance on the output and it won't affect it. How that affects the voltage. We're in current limit. So we're actually current limiting now to 1.6 amps. Now we're delivering 3 amps, over 3 amps, which is more than the transformer can handle, by the way. So I won't want to do that for too long. Now we're delivering 4 amps. Holy shit. Yep, that resistor's getting hot. So I'll dump that off. Dump that right off. Yep. Okay. Now there's one more little circuit addition I want to add to this thing, and that is a roughly 12 volt regulated supply out here that can handle a few MA. Reason for that is I want to drive a LED panel meter for the voltage and current, possibly a relay to control the load on-off output. Sorry about that. And this is a basic transistor Zener shunt regulator, which is a very common circuit. Got a 680 ohm resistor going between the collector of this BD139, which can handle about 1.3 amps by the way, and that gives us base bias to this transistor, and this Zener diode shunts it down to 12 volt at this point, so we get roughly 11.5 out here because of the drop of the transistor. And coming off the other side of the AC of the transformer, secondary, into a 47 microfarad 50 volt capacitor, just to give it a little bit of filtering. So on this side, when you turn the power off on the device, the display and any other LED connected to it goes off instantly. That's the idea. But I'm not going to build that today because this video is going on long, plus the battery on my camera is going flat, and yeah, I've got like 2 parts to this series now to edit, which is going to take me some time. And also I was thinking a few minutes ago that I might be able to come up with another different solution to this 5 volt minus reference voltage here, using that 11.5 volt regulator idea. So then I can eliminate the need to have a second transformer, and that's using 555 timer IC to generate a PWM signal going into an op-amp. The op-amp will then generate the negative output for us. There are other solutions, like there's actually a chip that can do it for you. I don't have that chip and I can't remember the number of the chip offhand, but that will give you an inverse rail to the positive. The JYE Tech oscilloscopes use a similar thing to power their op-amps. I'll have to look up the chip number and see where I can get the DIP package from, because that'd be something else probably I can explore as well, which might be a lot simpler than using an op-amp. It's still using another 8-pin device, but I want to keep the number of 8-pin dips on the final product down to no more than 2 if I can, because, well, we've got 1 here for the current limiting, and if we add a 555 timer, that's another one, and then you add an op-amp, another op-amp, that's 3 op-amps on the board. And using an op-amp to generate the negative rail plus a 555 timer is, well, probably unnecessary. There are other ways of doing it, but put your suggestions down in the comments. I'm thinking more of ordering some of these polarity inverter ICs. I can't remember what you call them, but yeah, anyway, I'll have to look it up. But anyway, I'm going to leave this video here for now. And also one other thing, this will probably now quite happily run on 24 volts AC. I can't be bothered getting another transformer out to test that theory, but I didn't just damage that IC when there was 50 volts going up its arse, so how, I don't know. But that's the goal. So in the next video I'll up the voltage to 24 volt AC, do some more testing, and come up with a better negative rail generation system. I still have to use the 5 volt regulator, but that's fine. But the power going into that inverter chip is important the maximum input voltage, so it will have to go through a regulator off of the main supply first before, you know, going into that chip in case it blows the arse off of it. So that's some homework for me to do, is to look that up and come up with a better system, and I'll build that up on another smaller breadboard and test it out just to see how well it works. And yeah, so you can look forward to that. But for now, that's it for part 3. I'm the Astro30. If you enjoyed this video, please remember to rate, comment and subscribe below. And if you want to, you can also follow me on Facebook, and you can become a Patreon supporter for as little as $1 a month. Links are in the description as usual, guys. Anyway, this is Astro30 saying, see ya, have a great day. I'm getting somewhere.